Hello, I'm Igor and welcome to another filament testing video, and this time this is the Prusament carbon fiber PC blend. Now, approximately 2 months ago I tested 4 Prusament filaments, and I mentioned there that I bought those filaments because I contacted the Prusament if they want to be reviewed and to send me some sample filaments, but I got no answer from them. And a week after I published the video, they contacted me and they apologized that they are overloaded with emails. I said no problem, so if they want me to continue this, they could send me some carbon fiber PC blend. And they were very kind, so they sent me this ASA, regular PC blend and carbon fiber PC blend. I'm not sure why, maybe they want to compensate me for that video, but in this video I am only testing the carbon fiber version, and it always arrives with this glue stick, and I will compare it with the regular PC blend, and I will include those results from previous video. But some experiments which are side-by-side comparison, I will use this. I reprinted these test objects from regular PC blend and I will include them in this video. Now, it is important to mention that with carbon fiber filaments you have to use a hardened nozzle because brass nozzles, they have great thermal conductivity, but they are not too very resistant to these carbon fiber types of the filaments. Maybe one thing I want to mention that I print this filament inside the enclosure which I'm using now several months, but I noticed that especially the extruder parts, because they are from PETG, some parts are a little bit deformed, especially the holder of the printer probe. I think it's a little bit lower. I have to raise the Z offset by 0.2 millimeters. I hope I can finish this video on this printer as it is now, but later I want to reprint all extruder parts from ABS, or maybe directly from the ASA. But before I open the box, let's see what information we have here. PC blend carbon fiber in black color, and printing temperature is between 275 and 295 degrees Celsius, and the bed temperature between 100 and 120 degrees Celsius. And I will use a glue stick on the surface. And this is the vacuum packaging. I really like this nice rolling of the filament. And again, we have here information that this is a PC blend CF black, and we have information about the printing temperatures. And this bag is resealable, so I have to open above this line, and after the printing I can place it back with some silica gel inside. Oh, it has so beautiful black texture, and I really like this nice rolling of the Prusament filaments. This spool is from plastic only from the sides. Here inside, maybe you can see it is from the cardboard. Maybe it will be good to see information about the empty spool weight. And just recently I figured out that on Prusament.com website we can enter the ID of the spool, and then we can get details of the product, which includes the weight of the empty spool. So I have to start with replacing the brass with the hardened steel nozzle. And for this I have to remove the part cooling fan. Then I will move the Z-axis higher so it will be easier working with it. And I'm removing the fan shroud too. If there is any filament inside, I have to remove it first. Now, it's a little bit hard to work and not to cover the camera, so I will explain it first. I will heat up the nozzle to 280 degrees Celsius, and I will hold the heat block with this adjustable wrench from this position. Very important, I don't want to damage the wires of the thermistor and heating cartridge. And then I will use a 7mm wrench to remove the nozzle. Don't forget, this is very hot, so put it on something that is not flammable. And now inserting the hardened nozzle. And now I can reduce the temperature of the nozzle. I hope it's visible on screen too, but there should be a small gap between this surface and the heat block. I'm placing back the fan shroud and the part cooling fan. And it's ready for carbon fiber filaments. This worked with the regular PC blend, so I'm using the smooth PI sheet with some glue stick on it. And there is it on the other side. This will be the temperature tower from 295 to 275. Only the author didn't prepare those elements above 265 degrees Celsius, but the set temperature will be correct. Print temperature tower from 295 to 275. It starts with the printing on 295 degrees Celsius, and looks like it is great so far, the first layer. And I hope it will stay like that. I read that carbon fiber is easier to print than the regular PC blend because the carbon fibers prevents a little bit of warping. Error max temp. What is this? Error max temp. So the printing was good so far. I'm not sure what happened. If I analyze the printing so far, it looks great, so I cannot see any kind of the problems. Sticks very good thanks to the glue stick. I restarted the printing of the temperature tower, but now from 285 degrees Celsius, and the bed temperature I reduced from 115 to 110 degrees Celsius. Now I know what happened. So on this height it starts with the fan very minimally, 20%, but that's the settings in the Prusa slicer. And on 295 it cooled down and it starts with the heating and probably shoots over that limit, and then I got the max temperature. So maybe it is better to completely turn off the cooling during this printing, but I just left the different settings in Prusa slicer for this filament. But now on 285 I don't see that I will have this kind of problems. And this is the bridging moment. The fan is on and I can see the temperature go down to 278 for the moment, and then goes up to 290 before it stabilizes again. And this is the last element on 275 degrees Celsius, and it looks okay so far. The printing is almost finished. Just to show you my setup quickly, I moved the screen outside so I can adjust it without opening the door. Well, actually I left it open a little bit because I don't want too high temperatures inside, which is currently 41 degrees Celsius. And also I moved this passive power supply unit outside. And I had a small cooling fan on the mainboard. Printing is finished, and immediately I want to check the bed adhesion, which looks like great. Look at this perfect overhang, perfect bridging, absolutely no problems with this surface. I will not even remove this glue stick, I will just add another layer because now the printing surface will be a little bit bigger, and I will print all test objects at once. And I will print test objects without brim as a first attempt. The first layer laid down perfectly, and I will try to print this without brim, and it will be a successful print. In that case, this is easier for printing than a regular PC blend. And after 1 hour, still perfect printing without any signs of the warping. And only 1 hour of printing left, and I hope everything will be okay with the mechanical testing, because this may easily become my new favorite filament. And last 2 elements for the layer adhesion test. The printing is finished and the temperature inside the enclosure was 42 degrees Celsius. I will wait until the bed cools down and then I will remove the objects. And now I can start the mechanical testing. I reprinted some parts because they will be tested after annealing in the oven. Now let's talk about annealing. Now on Prusament website there is a suggestion: if you want to raise the thermal resistance of this material, we can anneal it on 140 degrees Celsius for 2 hours. Now I know that this is something that most of the users will not do, maybe with the reason time consuming and really needs a lot of energy. For this size of the printing and this size of the oven, probably I will use more energy for the annealing than I use for the CD printing. The temperature stabilized now on 140 degrees Celsius, and now we insert now these objects in the same position as they were 3D printed. And I have one additional, which I will measure the dimension stability. To our paste, visually I cannot see any deformation on them, unlike I would see with the regular PLA, for example. Let's check quickly the dimensional accuracy. So I have here objects from PLA, PETG, ASA, polycarbonate, carbon fiber, polycarbonate, and annealed carbon fiber. In this video I will just measure one dimension, but I will measure of course more, and I will show you the results soon. Just to show you, so the PLA shrinks the less and it should be more accurate. This dimension should be 40 millimeters than PETG. And then ASA shrinks a little bit more than PETG. From these objects, the polycarbonate regular should shrink the most. And this is the carbon fiber version of the polycarbonate, and as you can see it is very close to that nominal value. And this is the annealed, and it should shrink less than 1%. So I measure everything in X and Y direction, and I will show you soon the results. In Z direction I have only these objects, and I notice in Z direction they don't shrink, they extend. Just to show you, so this is 38.07, and this is annealed, and it will be a little bit bigger, 38.24. And this is a summary of the measuring, and here you can see the values in percentage, the difference from the nominal perfect value. So 100% is the perfect dimension. And with the four basic materials, something what I expected. So the shrinking of the PLA is the smallest, so it is the most accurate. Then the PETG, ASA, and the biggest shrinking I had with the PC blend. And with the carbon fiber version of the PC blend, I get almost same accuracy in the dimension like with the PLA. And this is the shrinking of the carbon fiber filament after the annealing. And very similar values I got with the y-axis. Now in the Z direction, I measure only the carbon fiber and annealed carbon fiber. And here I experience actually that after the annealing in Z direction, the dimension expand. Now, what is this shrinking in percentage? Well, in X and Y direction, it is very similar, approximately 0.3-0.4%. And in Z direction, it is negative value. This means it extends, is between 0.4 and 0.5%. Keep in mind, for complex shapes, this is not so constant, so you cannot just compensate this percentage in design to get accurate printing dimensions. And now let's start with the mechanical testing. I'm starting with tensile strength. These test objects are printed in horizontal position, and the smallest cross-section area is 4x4 millimeters. And I'm starting with regular carbon fiber PC blend, and then with annealed version. Well, for the feeling it was okay, strong, but when I see this kind of cross-section areas, these are signs of the weaker layer adhesion, but I will find out that in few minutes. And now the layer adhesion test. These test objects are printed in vertical position, and first I'm starting with carbon fiber PC blend, and then with annealed versions. Well, unfortunately, this is something what I was afraid of. I still remember the feeling when I broke the regular PC blend, and I know that this is much weaker. And now this double-sided shear stress, the diameter of this test object is 5 millimeters. And it was shared correctly on those two cross-section areas. This means it is in 3 pieces. And now the torque or twist test. The diameter of cylindrical part is 6 millimeters, and this side goes into the vise, and the other side goes into this digital torque meter, which can record the peak of one movement. I want to record the load at 90-degree angle and the maximal load. 1.3. 1.3 was the peak. Oops, it's already broke. And this kind of break another sign of the weak layer adhesion. 3-point bending test. Distance between supports is 50 mm, and I want to record the load at 2 mm deformation and the maximal load. And this is the cross-section surface after the break. Now the isolated impact test with half kilogram hammer, and it will break this test object and swing to the other side, and from difference in height from the zero position I can calculate the breaking energy. And if I remember correctly, with the regular PC blend, the difference in height was 49 millimeters, and we will see what will we get with this carbon fiber version. Carbon fiber PC blend. Zero position. And it didn't broke completely. But now let's see the numbers. This is a zero position, and this is after breaking the carbon fiber PC blend, and difference in height is 63 millimeters. With the regular PC blend it was 49. And with this equation I can calculate the breaking energy. Now I believe that the most important property for these materials is the temperature resistance. And I want to record the temperature at the first deformation. And here I have the regular PC blend, carbon fiber PC blend, and the annealed version. And I will follow the temperature on this cooking thermometer. This is just a backup. And this is the time lapse of approximately 10 minutes. And you will see it was very hard to notice the deformation moment, even with the frame-by-frame analyzing. But you will see in a few seconds the final result, and the deformation is obvious. And approximately at 150 degrees Celsius, I noticed the first deformation on PC blend, and just maybe 10 or 15 degrees later the carbon fiber, and again later the annealed version. So I stopped the experiment here. It reached 200 degrees Celsius, and this one has a small delay. And something what I expected, I can see now the polycarbonate is completely down, the carbon fiber just a little bit deformed, and just a slight deformation on annealed version. But it was far above that specifications given in the website. But don't forget, this is not standard testing. This load is a little bit lower than that standard ISO 75. But this is my regular testing, which I always do with these materials. A little bit soft, not too much. These are hard, but I can see they are a little bit softer than when they are on room temperature. And just one more time to show you the deformation. So this is the regular PC blend, this is carbon fiber PC blend, and this is the annealed version of the carbon fiber. So basically, yes, the annealed version is the best in this experiment, but I think all three materials has great temperature resistance. And now my regular creep test, I will measure the deformation during the constant load. Basically I will measure the distance between these two reference surfaces. And since this creep test depend from the environment temperature too, I will include here the regular PC blend, and this is the carbon fiber version, and the last one is the annealed version. And I can see some minimal deformation after annealing, but it doesn't matter because with the creeping I need the difference between 2 days. And now placing the load, 1.25 kilogram. Interesting, the biggest deformation I can see with the regular PC blend, then the carbon fiber PC blend, and the smallest deformation on annealed carbon fiber PC blend. And I'm measuring the start values, and for more accurate measuring I am locking the position with this 3D printed object. 15.40. The deformation on carbon fiber is so small that I cannot place this M3 bolt in this gap. 12.89, 11.99. So this is how they look like after placing the load, and this is after 5 days. And now 1 hour on 50 degrees Celsius. 1 hour passed and one last measuring. 17.7, 13.8, 12.61. And now removing of the load. And here you can see the permanent deformation, so both carbon fibers almost get original shape and just a little bit more permanent deformation on regular PC blend. This Excel table is a summary of my results and it is downloadable from mytech1.com website. This is the raw data from the creep test, but what I need is the difference between 2 days. That's why I prepared this table, and this will be presented on a graph. Let's see the graph, it is easier for understanding. The result of the creep test. After 1 day, only I can see some creeping on the regular PC blend, but almost no creeping on the carbon fiber versions. But this is also very low value. After this, basically the creeping stopped. These are so small values that it could be even error in the measuring. And after placing 1 hour on 50 degrees Celsius, I can see some additional creeping, but in this order. So the biggest was with the PC blend, then carbon fiber version, and this is annealed version with the smallest creeping on this higher temperature. Tensile test, very similar values here. Now with the layer adhesion, there is a bigger difference. You can see the scale is similar, but anyway, this is acceptable. With the regular PC blend, 40 kilograms. But 50.7 with the carbon fiber version, this is very low value. And annealing helped a little bit, but not much. So this is something you have to keep in mind when you choose your printing orientation, for example. Now the shear stress was very similar in both cases. Bending test. This is the load at 2 mm deformation, and this value is more important compared to this one. This is just a maximal load, but this is not elasticity test. And here I have a bigger difference, and this is something what I could feel with my hands. I couldn't just bend that test objects from carbon fiber. And similar with the torque test, this is more important, the load at a 90-degree rotation. Very similar numbers. This is not so important. I mean, I don't need 2 rotations. This is again not elasticity material. And here they were very equal. Breaking energy, well, the carbon fiber version was a little bit better, maybe 30%. And the temperature test, basically all 3 materials are great in this test. The PC blend, I noticed the first deformation at approximately 150 degrees Celsius, but it was very hard to notice this even in analyzing frame by frame that time lapse. Very similar to carbon fiber, and of course the best was the annealed version. And other conclusions. Well, I think this is great material, but not because of the mechanical properties. Okay, it is better on bending and impact test and maybe a little bit on a creep test. But on the other side we have that weaker layer adhesion. We have to keep in mind when we create our designs or choosing the printing orientation. But the reason why I like this filament is its printability. It's much easier for printing compared to the regular PC blend. So we have less warping, better dimensional accuracy, and thanks to those carbon fibers, the shrinking after annealing is much smaller compared to the non-carbon fiber versions. All results presented in this video are downloadable from my website, and my Patreon supporters have access to that Excel table where I summary all results from my previous videos, including this one, and they can download it directly. Recently I noticed that we have new Prusament filaments, and that's nylon PA11. That's new filament by the Prusament. I don't have any experience with this type. I have experience with 6, 6.6 or PA12, but 11 is something new to me. And also I noticed that the Prusa will have a new sheet specially for this nylon material, and I hope I will have opportunity to test that too. I noticed that this filament, carbon fiber PC blend, is very commonly out of the stock, so I believe that a lot of you already tested this material. If you have some additional experience with it, you can share with us in the comment section. Thank you for watching and happy printing!